Hi there. All right, so we are going to start chapter 8 now, and this is on probability and statistics. So with our first section 8.1, which is what I'm going to talk about right now, we're really not doing anything that is new. What we're doing is we're actually taking our computations of various probabilities and organizing them in an efficient way. Okay? This section is called Distributions of Random Variables. Okay? The title is actually more complicated than the actual section itself. Okay? Now, you might ask, what is a random variable? Think about when you were in an algebra class. Okay? What we would do is we would let, for example, x represent some quantity. So we could let x represent the number of students in Math 115. Well, I think you'll grant me, depending upon which Math 115 class or semester, x is going to vary depending. Okay? That's what we mean by a random variable. It's something that changes. Okay, so let's take just a few examples and I will show you how to put these things into what we call probability distribution tables. Okay, we have seen these before. Now, one comment that I would like to make. Number one, you can never have a negative probability. And number two, if you add up all of the probabilities in a particular probability distribution table, it should add up to 1. Now, if you've got decimals and then there's some round off, okay, it's going to add up to 1 within round off error. Okay, so let's get started. And our first example is the following. Suppose you toss 2 coins and want to look at the possible number of heads that appear. All right, so this is our little experiment. So you have to ask yourself, what are we looking for? And it always will tell us what we're looking for. In this case, we want to look at the possible number of heads that appear. So what we'll do is let x equal the number of heads that appear. All right, now let's ask ourselves, what could x possibly be equal to? We have to figure out all of the different values that it could possibly take on. Okay, well, if we're tossing 2 coins, I think you'll grant me that x could be equal to 0, 1, or 2. Okay, since we only have 2 coins, that's about as good as we're going to get. All right, so I always like to make these tables go horizontal. So this is my random variable x. It could be equal to 0, 1, or 2. And then beneath it, we put the probability of x. Now, this is the type of guy we can actually even just write out our sample space for. Right? I mean, what could we have? We could have head, 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 tail, tail, head, or tail, tail. Most of these we're actually going to be using combinations, but this is one that we could actually just write out our sample space. So, what is the probability of getting 0 heads? Remember, the probability of an event is the number of ways it can happen over the total possible number of outcomes. Well, I think that there is one way that we can have no heads, and that there's 4 elements in our sample space. All right, so let's find the probability of getting 1 head. Well, that occurs here and here. So we can say 2 out of 4 times. And yes, that is 1/2. Okay, and last but not least, what's the probability of getting 2 heads? Well, that occurs 1 time out of the 4. So that's kind of the simplest type of probability distribution table. Notice if you add 1/4 plus 2/4 plus 1/4, you get 4/4, which is precisely 1. Okay? So that is one type of example. Now let's take another little scenario. Okay, our next scenario is going to be this. Suppose 2 balls are drawn from a bag containing, I don't know, how about 4 green balls and 2 purple balls. The number of purple balls is counted. Okay, so what we need to do now is make our probability distribution table corresponding to this scenario. Again, they tell us what we're actually focusing on here. So in this case, what I will do is I will let X represent the number of purple balls that are drawn. Okay, well, again, we have to figure out what possible values can X take on. Well, notice there's only 2 purple balls in the bag, so that's going to be the max we can get anyhow. And we're also drawing 2 balls. So again, in this case, X can be equal to 0, 1, or 2. Excuse me. Okay, now let's figure out how would we find the probabilities here. Okay, well, remember when you have a bag of something and you're choosing, that's my hint, a couple of them, and asking how many ways can it be done, okay, that should signal to you that we're probably going to be using a combination. Why a combination and not a permutation? Well, precisely because the order in which we select the balls does not matter. Okay? So, when you're asked to complete a probability distribution table, combinations should always be at the forefront of your mind. It doesn't mean that you're always going to be using combinations. However, it happens that it's a quite frequent occurrence. All right, so let's talk about this. First thing we have to get are our denominators. They're going to be the same throughout. Now, when you're completing a probability distribution table and you have combinations, that is one of the situations where I will actually ask you to compute them. Okay, well, how many balls are in our bag? We have 4 green and 2 purple, so I think you'll grant me that there's 6 balls in our bag, and we're choosing 2. So all of our denominators will look like 6 choose 2. Okay, now let's ask ourselves, in how many ways can we have 0 purple balls? Well, there's 2 purple balls. We're wanting none. Well, we're still picking 2 balls, and we know that there's 4 green ones, and therefore both of them must be 2. Your top numbers are not what's going to change. Remember our wonderful check mechanism? Your top numbers here need to add up to your top number, and your bottom numbers need to add up to your bottom number. All right, now we need to ask ourselves, in how many ways can we choose 1 purple ball? Well, there's 2 purple balls. We're going to choose 1. And then that also means that the other ball we choose is going to be a green ball. then last but not least, we want to know in how many ways can we choose 2 purple balls? Well, that's 2 choose 2 times 4 choose 0. Now, I encourage you guys to do these computations in your calculator. What you should get is 6/15 here. I'm not reducing any of my fractions. 8/15 and 1/15. Okay, I did these computations precisely so that you could be sure that you're computing your combinations correctly. And again, notice if we add up all of our probabilities, we have 15/15, which is precisely 1. Okay, now let's do a little bit bigger of an example. It's not a lot bigger. And in this case, what if I tell you, suppose 5 apples in a barrel of 25 are known to have worms. Lovely, huh? And suppose 3 balls, excuse me, I'm still back in my last example. Suppose 3 apples are selected at random. And the number of wormed apples is counted. I claim this is another situation where we can construct a probability distribution table. Again, we're being told what we're counting. In this case, we're counting the number of wormed apples. Okay, so now we need to ask ourselves, well, what values of x can we have here? Well, certainly we could choose 0 wormed apples, which is our ideal situation. Or we could have 1 wormed apple, or we could have 2 wormed apples. And in fact, since we're selecting 3 apples, we could have as many as 3 wormed apples. Notice there's 5 in our barrel, however, we're only choosing 3 apples. Okay, so let's go through and do our probabilities. Hopefully this will ring a bell for you that in fact what we're going to be using here, again, are our combinations. So the first thing I always do when I do my combinations is I always do my denominator, okay? Again, because I want to have that check mechanism there, and also because the denominator is the same throughout. So, how many apples are in our barrel? There's 25 apples, and we're choosing 3. Okay. Now, we need to ask ourselves, in how many ways can we choose 0 wormed apples? Well, there's 5 wormed apples, and we want none of them, which is kind of an obvious statement. All right, but remember, we're still selecting 3 apples. So, where are those 3 apples going to come from? Well, they're going to come from our unwormed apples, okay? How many of those are there? Well, if there's 25 apples in my barrel and 5 of them have worms, I think you'll grant me then that 20 of them do not. Okay, again, notice our check mechanism. Our top numbers add up to our top number. Our bottom numbers add up to our bottom number. All right, now, as we go, our top numbers are not going to change at all because we're still making the distinction between wormed apples and unwormed apples. The only thing that's going to change are our bottom numbers, but they always have to add up to 3. So, in how many ways can we have 1 wormed apple? Well, we want 1 wormed apple, and therefore 2 are not wormed. Now we want 2 wormed apples, and therefore, since we're picking 3, 1 is not going to be wormed. And last but not least, we want 3 wormed apples here, and therefore, none of them will be decent. Okay? Now again, I did these computations precisely so that you could do such on your own calculator and make sure that we get the same answer. All right, again, I'm not reducing my fractions because I want to be sure that our numbers jive. So this one, you should get 1,140 over 2,300. This one is 950 over 2,300. Here we have 200 over 2,300. And last but not least, we're going to have 10 over 2,300. And I claim if you add up these 4 fractions, you're going to get 2,300 over 2,300, which gives us 1. All right, so this is what is going to help us organize our information for the next few sections when we talk about expected value and then when we talk about standard deviation and variance. Thank you.